In this video, I want to have a look at the standard forms of a parabola. Now, in this video, we're only going to look at parabolas that have a vertex at the origin and have a directrix that's parallel to either the x or the y axis. So if we look at those, there's 4 different parabolas or standard forms of a parabola that we can have. So the first one is the one that we're most familiar with. We've got a parabola with vertex at the origin and it's concave up. Now, its focus would be the point 0a, and the directrix would be y equals minus a, because that a there is the focal length, so the distance there. So the equation of that parabola would be x squared equals 4ay, and again that a is the focal length. So we'll have a look next at a concave down parabola. So we've still got that same vertex, we still have a focal length of a, then our equation would be very similar, except we're going to have that negative in front of the 4. So we'd have x squared equals minus 4ay. So the next two are ones that we're not as familiar with. We've worked with concave up and concave down parabolas before, but now we're also going to start talking about right and concave left parabolas. So we've still got that same vertex, we've still got a focal length of a, but this time our parabola is concave right. So instead of being x squared equals 4ay, we're going to have y squared equals 4ax for a concave right parabola. And I'm sure you probably guessed by now that the equation of a concave left parabola would be y squared equals minus 4ax. So it's still got that same vertex and the same focal length of a. So let's have a look at some examples. So we've got, for each parabola, find the focal length, the coordinates of the vertex, the coordinates of the focus, and the equation of the directrix. So for question 1, well, for all of these, we're going to draw a really quick sketch first. So we'll draw our x and our y axes. We know that this, looking at our 4 standard forms, we've got an x squared and we've got a positive coefficient of y. So that means it's going to be a concave up parabola. So figuring out the orientation of our parabola first. Then we need to use this number here to figure out our focal length. So our standard form says x squared equals 4 times the focal length, y. So we've got that 4a in this one is equal to 24. So that means that a, our focal length, is going to be equal to 6. So that's our first one, find the focal length. Then we need to find the coordinates of the vertex. So our vertex for all of these is just going to be 0, 0. So far we're just talking about those, all of our parabolas that we're talking about, will have a vertex of 0, 0. We'll talk about moving them around that number plane later on. Then it asks us to find the coordinates of the focus. So if we've got a vertex at 0, 0 and we have a focal length of 6, that means that our focus is going to be up here at 6. So our focus will have coordinates 0, 6. And the last one, it asks us to find the equation of the directrix. So the directrix will be going along here, and it will have an equation of y equals minus 6. Let's have a look at our second one. So again, we'll draw a really quick, rough sketch. So we've got x squared equals minus 4y. So that means that this one's going to be a concave down parabola. So our focus will be down here somewhere, and our directrix will be going along here. So that coefficient of y is going to help us find our focal length. So we know that 4a is equal to 4, which means that a is equal to 1. So our focal length there is 1. Now again, we know that the vertex is 0, 0. So our focal length will go down 1 unit. So that means we'll end up with our focus at 0, minus 1. And our directrix will be up 1 unit. So we'd end up with the equation y equals 1. And for our third example, one more diagram. So we've got y squared equals 2x. So that's a concave right parabola, which means our focus will be up here somewhere, our directrix will be over here. That 4a is going to be equal to the coefficient of x this time, which is our 2. So that means that a is going to be equal to 1/2. So our vertex is still in that same position of 0, 0. Our focus will be half a unit to the right. So we're actually going to have coordinates 0, sorry, a half, 0, so we've moved half the unit across. And our directrix will have an equation of x equals minus a half. I want to have a look now at some examples of going the other way. So we're told the focus and the directrix, and we're asked to find the equation. So we'll still start off by drawing a really quick sketch. We know that our focus for this first one is at 0, 5, so up here, and our directrix is at y equals minus 5. So looking at where those two points are in the direction of our directrix, then we can see that our parabola is going to be concave up. So that means it's going to be in the form x squared equals 4ay. Now using our diagram, we can figure out that our a is equal to 5 because we know that all these parabolas have a vertex at 0, 0. So that's 5 units there and 5 units down here. So we can substitute that in. We'd have x squared equals 4 times 5, so 20y. For our second question, again, quick sketch. We've got a focus of minus 2, 0, so that's a focus over here, and a directrix at x equals 2. That should have a minus 2 on it there. So looking at those, we can see that our parabola is going to be concave left. So that means it's going to have an equation in the form y squared equals minus 4ax. We can tell from our diagram that our focal length is 2 units. So our equation is going to be y squared equals minus 4 times 2, so minus 8x. So I'll have looking at a few examples to do with standard equations of parabolas.